Hey Jenny, I finally went to the museum in Berlin I kept talking about. I went to the museum for Naturkunde.
That's great, Ryan. Was it worth it? I remember how excited you were before going. You kept saying this trip would feel different, like you'd finally see dinosaurs in a way books or videos never show. So tell me, did it actually live up to that expectation? Or was it just another museum visit?
Worth it? It completely blew my mind. And Jenny, they have this massive Brachiosaurus skeleton there. It's actually in the Guinness World Records as the tallest mounted dinosaur skeleton.
I've seen pictures of that place, but pictures always feel so controlled. You never really get a sense of scale. When you were standing there, did it actually make you feel small? Like physically insignificant compared to something that once lived?
That's the thing, you can't imagine it until you're standing under it. I walked into the hall, looked up, and just froze. The neck stretches up like, I don't know, like a crane made of bones. It doesn't even feel real. You suddenly realize this was a living animal.
That must have been surreal. It's like your brain has to reconcile two completely different realities at once. You're looking at dry, silent bones, but at the same time, you're aware that this structure once carried life, movement, maybe even behavior we can't imagine. That contrast alone must make the moment unforgettable.
It really was. But what made it even more incredible were these simulation screens right next to the fossil. At first I thought, okay, just another museum animation. But then it started.
What did it show? Was it more educational? Or something immersive that actually pulls you into the experience emotionally?
It begins with the exact skeleton, the same one standing in front of you. Same proportions, same posture. Then slowly, layer by layer, muscles start forming over the bones. You can see how the body builds up, like watching anatomy come alive.
That already sounds powerful, because it's not just showing you something, it's teaching your brain how to see. It's guiding your imagination step by step, almost telling you, this is how you should interpret these bones.
Wait, it gets better. After the muscles, they add skin, texture, movement, everything. And suddenly, it's not just a skeleton anymore. It's a full animal. And then, it starts walking.
Walking? That's a huge leap. From something completely static to something dynamic. That's where it stops being just science and starts feeling like reality. Or was it more like a cartoon?
Yeah, the screen transitions into this prehistoric forest, and the same dinosaur you were just looking at as a fossil. Now it's moving. Slowly, heavily, but gracefully. Trees around it, light filtering through. It feels alive.
I can imagine that moment being almost overwhelming. Because your eyes just saw the fossil, and then suddenly your brain is shown a living version of it in the screen. Although it's just walking in a screen, it's like time collapses. Millions of years disappear for a second.
Honestly, I couldn't stop going back and forth. I'd look at the real fossil, then turn to the screen, then back again, over and over. My brain was trying to connect the two. The dead, silent bones, and this massive living creature.
Like your imagination wasn't free anymore. It was being constructed, directed, almost engineered by the simulation.
Exactly. It wasn't just imagination anymore. It felt almost reconstructed. Like the museum was saying, this is what it was.
And that's a powerful statement. Because when something is presented with scientific precision, we instinctively trust it. We stop questioning and start accepting.
At that moment, completely. I was amazed. It felt so real, so scientifically grounded. You trust it because it looks precise, detailed. But later, on my way back, something started bothering me.
What do you mean? Did the excitement wear off and give way to doubt? Because sometimes when something feels too convincing, It actually triggers more questions than answers.
I kept thinking, how much of that did we actually know? I mean, we have the bones, sure. That part is real. But the muscles? The skin? The way it moved through that forest?
You're questioning the reconstruction, and that's completely logical, because each layer added after the fossil isn't directly observed. It's inferred, modeled, interpreted.
Yeah, because no matter how advanced the simulation is, there's no way to validate it completely. No one has ever seen a living dinosaur. We're filling in gaps. Educated guesses, sure, but still guesses.
So the same thing that amazed you also made you skeptical. That's actually the most scientific reaction possible. Because science isn't just about believing what looks real, it's about questioning what cannot be verified.
Exactly. That's what stayed with me. I was standing there switching between fossil and simulation, feeling like I was seeing the past come alive. But now I'm wondering, was I seeing reality or just a very convincing interpretation?
That question goes much deeper than just one museum visit. Because what you saw there is actually a simplified version of what scientists do. Think about it. The fossil. That's real. That's measurable, observable evidence. But everything beyond that requires reconstruction. First, scientists digitize the bones. Then they estimate muscles, based on attachment points and comparisons with modern animals. Then they assign mass, joints, constraints. And then comes the hardest part, movement. It's trying to answer a very specific question. Given this structure, what movements are possible?
Yeah, and I think that's the key realization. How do we know that final image of the dinosaur is true? Because we can validate the fossil, we can measure it, test it, compare it. Dinosaurs are one of the best studied prehistoric life forms we have, but we cannot validate the final image of the dinosaur. We cannot validate its skin. We cannot validate its exact motion. We cannot validate how it really existed.
But what we don't know is just as important, and maybe that's what we often forget.
Exactly. We'll never hear them, never watch them move in real life. Everything we build, every image, every simulation, is ultimately a bridge between evidence and imagination.
Do you know, Ryan? One of the most well-known dinosaurs people always talk about is the Velociraptor. It shows up everywhere, in books, movies, documentaries, you name it. Scientists have found around 15 or so fossil specimens of Velociraptor. That's a lot compared to many other dinosaurs. And even with those fossils, for a long time there were still doubts and debates about what they really looked like, especially when it came to whether they had scales like reptiles or feathers like birds.
Yeah, I've heard about that before, and it's kind of wild how much the idea has changed over time. For years, the common assumption was that velociraptors were basically like reptiles, scaly skin, lizard-like appearance, the whole thing. That image got really popular, especially because of the Hollywood movie Jurassic Park. In the movie, they showed velociraptors as these scaly, menacing predators. But now scientists think that whole picture was actually pretty inaccurate, and that they were much more bird-like, with feathers covering their bodies.
Exactly. And what's really important is that this shift in thinking didn't just come out of nowhere or from guesswork. It was based on actual fossil evidence that scientists carefully studied over time. In particular, discoveries from fossils found in Asia played a big role in changing their understanding. Researchers found these structures called quill knobs on the forearm bones of Velociraptor, which was a huge deal.
Quill knobs? That sounds kind of technical. What exactly are those supposed to be?
They're actually pretty easy to understand once you picture them. Quill knobs are small, raised bumps on the surface of the bone where large feathers attach to the arm. You can see the same kind of structures in modern birds today, like eagles and vultures, where their flight feathers are anchored. So when scientists found those same bumps on Velociraptor fossils, it was really strong, direct evidence that they must have had feathers too.
That's honestly fascinating. It completely changes the way we imagine them. Instead of thinking of velociraptors as these scaly, reptile-like creatures like in the movies, now we need to picture them as more bird-like animals, maybe even with wing-like arms covered in feathers.
Exactly. It really reshapes the whole image people have had for decades and makes them feel a lot closer to modern birds than to the classic idea of reptiles. But if you think about it, there is no way to be absolutely sure which final image of Velociraptor is actually true. Like you just said, we will never watch them move in real life.
Maybe that's the most honest conclusion we can reach. No matter how advanced our science becomes, no matter how detailed our simulations are, dinosaurs will always remain quite unknown to us.